This antibiogram of this particular isolate characterizes a methicillin-resistant Staphylococcus aureus isolate that demonstrates resistance to beta-lactams, fluoroquinolones, and macrolides, while maintaining a broad profile of susceptibility across several critical classes, including glycopeptides, lipopeptides, and oxazolidinones. Detailed resistance analysis. The susceptibility profile of this methicillin-resistant Staphylococcus aureus, MRSA, isolate provides significant insight into its phenotypic resistance patterns and the underlying genetic mechanisms at play. 1. Beta-lactam resistance, the MRSA phenotype. The isolate shows an oxacillin MIC of 2 grams milliliter, which confirms its status as MRSA. This resistance is characteristically mediated by the MEK-A gene, which encodes an alternative penicillin-binding protein known as PBP2A. Unlike standard PBPs, PBP2A has a very low affinity for almost all beta-lactam antibiotics, including penicillins, cephalosporins, with the exception of ceftaroline, and carbapenems, rendering the entire class clinically ineffective, regardless of other susceptibility markers. 2. Fluoroquinolone and macrolide resistance. Ciprofloxacin MIC 2 grams milliliter. The isolate is resistant. Resistance to fluoroquinolones in S. aureus typically arises from spontaneous mutations in the quinolone resistance determining regions, QRDR, of the gyre and GROL-A genes, which encode DNA gyrase and topoisomerase 4. This is a common feature in healthcare-associated MRSA strains. Erythromycin, MIC 4 grams milliliter, versus clindamycin, MIC/0.25 grams milliliter. This is a notable dissociated phenotype. The isolate is resistant to erythromycin but sensitive to clindamycin. This pattern suggests an efflux pump mechanism, often the MRSA gene, rather than ribosomal methylation, the genes. If genes were present and constitutively expressed, both would be resistant. If were inducible, a D-zone test would be required to confirm if clindamycin resistance could be triggered during therapy. 3. Preserved susceptibility to critical agents. Vancomycin, MIC 0.5 grams milliliter. This is a very low MIC, well within the susceptible range, less than 2 grams milliliter. It indicates that the cell wall precursors remain vulnerable to glycopeptide binding and that the VAN-A gene cluster is absent. Daptomycin, MIC/0.25 grams milliliter, and linezolid, MIC 1 grams milliliter. These represent the heavy hitters for MRSA. The low MIC suggests that the cell membrane structure for daptomycin and the 23S rRNA binding site for linezolid have not undergone the mutations often seen in highly refractory cases. Alternative agents, the isolate remains susceptible to tetracycline, trimethoprim, sulfamethoxazole, and gentamicin. This broad susceptibility to non-beta-lactam classes, despite being MRSA, is sometimes characteristic of community-associated MRSA, CA-MRSA clones, although molecular typing would be needed for confirmation.